Good afternoon and welcome. Our speaker today is Mr. Jim Francis. Jim is the Chief Executive Officer and owner of MicroAnt. MicroAnt is a technology company that develops and manufactures antenna technology for aerospace, military, and commercial applications. The company manufactures all of the antenna components in its own production shop using precision CNC machines. MicroAnt employs mechanical, electrical, and industrial engineers and continues to hire UF graduates. The company was incorporated in 2001 and began its manufacturing operations in 2003. Prior to joining MicroAnt, Jim was the owner of First Coast Energy, a joint venture with the Shell Oil Company. He also served as president of Charter Oil Company and was a partner with Smith and Hulsey law firm in Jacksonville, Florida. Jim earned his undergraduate degree from the McIntire School of Commerce at the University of Virginia and his Juris Doctorate from the Levin College of Law here at the University of Florida. Jim, the floor is yours.
Thank you very much. My background is entrepreneurial. I got that in undergraduate school and in law school. The education was such that it helped me be able to do the analytics associated with entrepreneurial things. So when I started practicing law, I represented large publicly held companies, small businesses, all sorts of things. And I found that my skills in business were as good, if not better, than my skills in law. People started offering me jobs, not as to practice law, but to work in their companies. I finally, after 10 years of practice law, took a job as the president of a large publicly held oil company. And then several years later, started my own oil business. And after I sold my oil business, I had nothing to do. So I was doing all sorts of different things. And I ran into these guys in the Boston area. I lived in this area part of the year. Ran into two engineers who were starting off this antenna business. And they wanted me to invest in this antenna that they were going to develop. And they described it to me. It was fascinating what this antenna was going to do. I was intrigued by the technology. And I said, well, who's going to buy it? And they said, everybody. I went, no, that's not how business works. You find a customer, they'll build it and they will come. Some people do it that way, but not I. That's not a good way to start a business. So I said, look, I'll help you for free for 6 months. I can get you on your feet, get you going. And after 6 months, it was apparent that I needed to keep doing it. So I kept doing it for free, but I took an interest in the company. And after, they still couldn't afford to pay me for a few years, but after several years, the company started doing extremely well. And what they were doing when I met them, which was the problem with their business, is that they were using their intellectual property to generate income by charging an hourly fee to their customers. Terrible business, because at the end of the day, you have no money. You've got no business. You just have to keep working on an hourly basis to generate revenue and profits. So what I did is I retooled the business. So instead of selling hours of time, engineering time, we began incorporating our intellectual property into the products that we produced. I don't know whether any of you have ever read Blue Ocean Strategy. It's a book of 20 years old, but it's an excellent book. And the theory of the book is that you use whatever you have available to position yourself in a way that you don't have a competitor. typical example is Ford Motor Company. When Henry Ford started Ford Motor Company, he started it. People said, how are you going to compete with all these different automobile companies? He said, they're not my competitor. I said, well, what do you mean? Who's your competitor? He said, the horse. So he did his business around the horse being the competitor, and all he had to do was sell the cars for less than what a horse and a buggy would sell for. So that's a perfect example of the way we run our business. What we do is we incorporate our intellectual property into products, and then we sell that product as a unique product to only one customer. And so that customer, using our intellectual property that's incorporated in our antenna product, they can go exploit the market without a competitor. And so we sell that one product only to that customer. Of course, as soon as we finish making that product for them, the concern is, well, wait a minute, how do we trust you that you won't sell it to somebody else? And we say, well, we don't want to be in the commodity business. If we sell the same product to your competitor, then you both come back to us and say, nice work, you split the business in half. And now in order for us to make a profit, we have to compete on price. And so we don't do that. And still then they're concerned that we might increase the price to them. We never increase the price. We have products that we've been selling for 15 years that we've never increased the price a penny. And we have that reputation in the industry. We don't do any marketing. All of our customers come to us because of our reputation. And our reputation is that we make the antenna products smaller, lighter weight, higher performing, using our existing intellectual property or intellectual property that we have developed in the process. And they come to us not because they might not be able to do it with their own antenna group. So we deal with a lot of the large defense contractors, but that their antenna group is not as efficient as we are. They will make a product that doesn't perform as well, and it will cost more. So they come to us for that purpose. So in everything, and this is hard for people to fathom, we don't have a competitor. By definition, we don't have a competitor because we will never compete in a commodity type product. We always wait for the customer that is stuck on whatever the problem is. For example, we had a large defense contractor come to us, and they had tried 2 other antenna companies on a particular product. Both the antenna companies had failed. They came to us. They'd burn up all of their funding. They'd burn up all of the schedule, and they had us try to make the product for them, which we did. It was successful, and we sold it to them. That's a typical thing that happens to us. Now, in the antenna business, it's really interesting. You think, well, what's an antenna? Well, the antenna business, there's a lot of intellectual property that's necessary because the frequency of the satellites keeps going higher and higher and higher, which makes the antenna much more difficult to make. And then the customer wants something that's smaller and lighter weight and wants high data rate. The more difficult the antenna problem, the better the opportunity is for us. So now, in my title of my talk, I talked about how we create prosperity globally. Let me give you an example of that. One of our customers came to us some years ago and said, look, we need an antenna, a GPS antenna with all the active electronics in an active GPS antenna that has millimeter accuracy. And you might wonder, why do you need millimeter accuracy? You don't need it in a car, you don't need it in a boat, don't need it in an airplane. But in some things, millimeter accuracy is very valuable. And this particular product was to be used for agriculture. And our customer was going to take our antenna product. We sell our products to systems integrators. Take our antenna product and integrate it into their terminal, and then they would sell that terminal into the agricultural business. And it would go on tractors. Now, the tractors are unmanned, and they can be operated, thousands of miles away from where the tractor is. And then the tractor goes and it prepares the field. And as it's preparing the field, it tests the soil throughout the field. So it knows the soil content for everywhere that the seeds will be placed. And when it plants the seeds exactly in the position that it knows it's planting the seed. And then when it fertilizes the field, it doesn't fertilize the field, it fertilizes the seeds with the exact formula that seed needs. So you can see how the artificial intelligence of how to do the farming is being taken care of because of the usefulness of our antenna. So food production, it just explodes when a customer buys our product that's included in the product that our customer sells. And they sell these things worldwide. So I tell our employees, I said, look, what we're doing is we're enhancing the food supply worldwide with our product. It won't work without our product. So we sell tens of thousands of these antennas a year to this one customer who incorporates it into their terminal, and then they sell it to thousands and thousands of customers. Another example that is a good one is the oil and the gas, water, and electric utility business. It's a very hands-on business, though, historically. However, what our customer has done, they've come to us and said, what we want is an antenna that we can put wherever the meter is. And we want to have a smart meter that'll turn on and off automatically through your antenna. And we want data collection unit in a grid for the area. And that data collection unit, we want to be able to spread those data collection units as far apart as they can, such that the public utility can be operated remotely. Again, it doesn't even have to be in the area where the antennas are. It can be anywhere, really. So the utility can turn on a meter, turn off a meter, can detect a leak, a gas leak, an oil leak, a gas leak or a water leak. And again, with the electric meter, the same thing, turn the meter on and off. So that enables the utility to operate more efficiently and lower the cost of the products that it sells to its customer base. Now you might think, well, okay, it's putting people out of work, but the work that was being done was fairly mundane, but the savings that they're able to provide to everybody in the area is massive. Another one is satellite communication. Satellite communication can provide high-speed internet anywhere in the world. We work with Inmarsat and Iridium, and they have global coverage with their satellites. And the idea is, I think you probably remember some years ago, there was a company called O3B. We made their first antenna that they were going to use for a ground terminal many years ago. And O3B stands for the other 3 billion, the 3 billion people in the world that have no access to the internet. And that was the plan that they had. So far, it hasn't been successful. The reason it hasn't been successful is that the cost of delivering that service for the last mile, they say mile, it could be 5 miles, could be 10 miles. That last mile is so expensive, they haven't quite gotten it figured out. But there's now worldwide communication that's available through the internet. And we provide antennas for that. Inmarsat, it provides it in L-band and in Ka band, and we provide a lot of the antennas for that. Inmarsat announced in Barcelona at a conference I went to last year that they had deployed their 8,000th Ka band terminal. They call it Global Express. and I started doing the math in my head, and 6,000 of them were ours. So we had a sizable percentage of the marketplace. Again, I said we don't have any marketing. Our customers find us, and you know, we have representative customers: Inmarsat, Iridium, Boeing, Thales, Lockheed, Harris, L3C, SpaceX, Google, Apple, and with antenna problems. Our company has 65 employees now. The guts of it are people who manufacture the products, but we have 15 engineers, and 3 of them are from the University of Florida, and but we have engineers from Stanford, Purdue, University of Virginia, Virginia Tech, Georgia Tech, Johns Hopkins, UMass, and Tufts. We hire electromagnetic engineers. Now, electromagnetics is the key, and there's not much electromagnetics taught in undergraduate school. So the engineers that we hire in the electromagnetics either have advanced degrees, PhDs, masters, that sort of thing, or have some significant experience working at some company that taught them electromagnetics. And then they come and work for us, and they're taught again by our chief scientist how we do the electromagnetics, how we develop the intellectual property and execute it. And we have, of course, RF engineers who do the circuit board designs and the development of the active electronics that are incorporated in our antennas. We're working on now an airborne antenna where the beam is electronically scanned. So instead of pointing the antenna at the satellite, the antenna electronically points at the satellite. And you might know that there are geostationary satellites that are stacked up on the equator all the way around the world. And they're also low Earth orbit satellites. These low Earth orbit satellites are moving. So in order to have an antenna work with those low Earth orbit satellites, unless it's a omni antenna, which has a hemispherical antenna pattern, you have to have the antenna electrically or mechanically point at the satellite for it to work. So our RF team does the active electronics, which includes transmission active electronics with power amplifiers, or low noise amplifiers for receive. And these electronically scanning antennas are very sophisticated and very expensive, but necessary if you have a vehicle, airborne vehicle, ship, whatever, moving at the same time as the satellite's moving. And so we do that. And you can have a large antenna that's mechanically pointed at the satellite, but there's a real demand for the electrically scanning antennas, which are pointed at satellites. So we have electromagnetic engineers, RF engineers, mechanical engineers. The mechanical engineers are necessary because the electrical engineers, they design the thing, which is basically airspace. And then mechanical engineers have to figure out how to put that together. And we have industrial engineers and manufacturing engineers that try to figure out how we're going to actually, after we've designed it electrically and mechanically, how we're actually going to make it and be successful at making it. We even have a biomedical engineer who is our program manager. She's brilliant, and she understands all of it. The way our business works is we get a customer will come to us with an idea of an antenna. And the first thing we do is we try to determine if their business plan makes sense. So you might think, well, that's not your job. Well, it is our job, because if they don't sell a lot of these products, then we don't sell a lot of antennas. So we go through their business plan, their business strategy, and make sure it makes sense. We make sure that they're a strong company. And while we have worked with some large companies that are unprofitable, but hope to be profitable, and some smaller companies, we generally try to work with companies that have the ability and strength to pay us. And because our antennas are so important to their business, we figure they'll pay us before they pay other suppliers. But we really try to figure out whether the business plan makes sense. We decline about 50% of the opportunities that come to us, either because the business plan doesn't make sense, or we just cannot fit it within our scope. We have too much business to handle. Our process is that the electromagnetic engineers start out with the antenna. How do we actually make this thing that has never existed before? We're making something unique. We've got our intellectual property. How are we going to adapt our intellectual property to make this thing work? And they start out with a design. Then it goes to the mechanical guys. Mechanical guys say, okay, well, here's how we'll have to make it. Then it's back and forth to the electrical guys. No, you can't modify it that way, it won't work. And then it comes down to the industrial and manufacturing engineers to have them go through the diligence of making sure it's manufacturable, and manufacturable at an attractive enough cost where we can sell it to our customer and they'll be satisfied with the cost, but also where we have a high gross profit. And then we'll manufacture a prototype. We have anechoic chambers, 2 large anechoic chambers in our facility where we'll test these prototypes. And then we'll do first article testing. And we use the first article testing in order to develop a comprehensive test report that our customer can submit to different agencies. It might be the FCC, it could be the satellite operator, it could be the federal government. The federal government owns the RSTRAT system for a satellite network that is proprietary to the military. And so we have developed these anechoic chambers where we can provide the comprehensive test report that is submitted by our customer to the agency, and that agency uses that documentation in order to certify the antenna for operation. And they know us well, so when they see the documentation coming from us, they accept that. Then we'll go into production. What we found out in production some years ago is a lot of our parts are made out of aluminum, and that the tolerances on the parts is so specialized that an outside machine shop that is a normal machine shop either cannot make it to those tolerances consistently, or if they can, the lead time and the cost is very high. So we started buying precision CNC machines and that have micron accuracy. So we're able to make the parts in our own machine shop, and we have to do it this way. It's not we have a choice. There's no machine shop that we could work with that could do it the way we need it done. So we started our own machine shop. We're actually looking at expanding our machine shop to another machine shop in the future. And then after we've done that sort of manufacturing, we don't do the circuit boards in-house. We design them and have them manufactured outside, and then we'll combine everything together and go into production. We spend in our development expense and our research and development, our development expense for different antennas, about $3 million a year. And $3 million a year is an expenditure not just of capital, but it's engineering expense, such that we continue to advance our intellectual property and add more production to our bottom line. So the $3 million is a lot of money, but it is essential to continue to increase the productivity of our operation. So, Dr. Fitzcoy, that's the end of my active presentation, but I'm available to respond to any questions that anyone has and talk to. Oh, one more question. COVID hit us like it did everyone else, but the way we handled COVID was a bit unusual. The first thing is that we immediately, before there was too much of a threat of what was going to happen, we immediately got instructions from a few of our customers that we were not allowed to shut down because of the Defense Procurement Act. So we got DPA instructions, and we were not going to shut down anyway unless we had to, but we were told that we could not. So what we did is before there were any instructions about masks or anything like that, what we did is we developed our own plan. And our plan was that we would clean every horizontal surface in our building twice a day. We would clean every vertical surface, like doorknobs, handles, continuously during the day. We would bring in food. No one was allowed to bring food in. We bring in lunches, ordered lunches from one particular vendor. Everyone could order their individual lunch, and then people could eat it separately. We didn't want anybody bringing in food from the outside, and that people would wear masks. And in doing that, we were 100% successful, and no one came down with the COVID-19. More recently, though, in the last week, we had one of our employees was out with some visitors to his house, and he got the virus from them, but did not bring it into the building. So we've actually increased production because the demand continues during the pandemic.
Okay, thanks, Jim. This time, are there any questions for our speaker? Well, while the audience formulates questions for you, Jim, quite interesting presentation there or talk there. I'm intrigued at the route you took to get to become now a antenna expert. I'm curious though, you made mention of the antennas that you have for global communications, and we're familiar with SpaceX, and well, I guess OneWeb is no longer here. Hopefully they'll come back. How big are these antennas? Because the satellite phones that I've seen in the past, they typically are not your cell phone size things because of the power requirements. So how big are these devices now?
That's a great question. The antennas that are used for communicating with Ka band have to be a large enough size because of the frequency in order to meet the satellite requirements for communication. So you would expect a Ka band satellite to be a minimum of 60 centimeters in diameter, and that same size if it were a flat panel antenna. And but they're used for soldier man packs. They'll take a flat panel antenna that we sell, it's 17 inches by 12 inches, and they'll put it in a small package and then go out and set it up, point it at the satellite, get communication, then put it back away. Also, these antennas will be able to be carried around in man packs, with the parabolic reflector, if it's a parabolic reflector, be disassembled into segments and then packed in a small case. So you've got carry-on size antennas, that kind of thing. Now, if you want a handheld device, you're going to have to operate in a slightly different way than the traditional way of operating. The reason we use these larger, I call it 60 centimeter antenna, the reason we use those is that the user is demanding a data rate through the satellite of about 10 megabits per second up and down. And you need that in order to it. Now, we think about, we live in the United States where we have these cell phones and you can get streaming video on your cell phone pretty much everywhere. But that's not the case elsewhere. If you're around a cell phone tower, and there are not too many of those in the ocean, right? So if you're in the ocean, you have to have something that's different. Or if you're in a hot zone somewhere where it's hostile, you're going to need that sort of communication device. And of course, the cost of those is a lot more than a cell phone. And then you've got the antennas that go on top of airplanes, where we do those aircraft antennas, and those are smaller, but you're using them on a little bit lower frequency, but still pretty good data rate.
Okay, so the takeaway there is that the data rate drives the size of the antenna. You want lots of data, you're going to have a big antenna.
Exactly. And now for safety, these soldiers are out there and they want to know what's going on over the next hill. They don't want to go over there if it's a hot zone. So they can have a UAV flying over that's streaming directly to the satellite and down to them, and they can see exactly real time what's going on. And that's what we offer.
Okay. Here's a question from Professor Dixon. I was curious where you see your bottlenecks. Are you pushing against the laws of physics, or are your bottlenecks more manufacturing, design, and financial limits?
We've been fortunate not to have the financial limit as a bottleneck, but we do have, since we're inventing things, everything is unique. We don't have any legacy products that we sell to other people. Our bottlenecks tend to be getting it through the design phase and into the manufacturing. And sometimes the bottleneck occurs in the design phase where the electromagnetic and mechanical engineers have come to a solution. But then in the actual production, that is not a truly producible product. And so that can be a bottleneck. And then sometimes the production in our machine shop is not such that we can push it through on a high volume basis. We've got one customer that told us that instead of their normal 200 units per year of this very high valued product, because of their customer demand, they were going to need us to produce 1,000 units in a very short period of time. So it's great to have that big purchase order. It's great to have that production, but we still have to do it. So the bottlenecks tend to be either in the getting it from the electromagnetic design into production or into production afterward. And it varies from time to time.
Okay. Here's another question from Professor Banks this time. Fabulous explanation of your work. When I visited your shop, I was struck by how mechanical your electromagnetic devices appear. It's a great example of multidisciplinary teams. I know you hire engineers for full-time positions. Are there internship or co-op opportunities for students interested in your company?
Sure. we like to hire interns. We've hired interns from Florida before, and we like to hire interns. But our goal is to hire permanent employees. If the engineer comes and works with us, they will not be put in the back room, doing drawings and things like that on their computer. They're going to be actually working with the electromagnetic engineers, coming up with the designs. They're going to be creating new things themselves. There's no legacy design that they're working off of. So we think it's an exciting place to work, and it's a secure place to work from a point of view of future employment. But we're not Harris. Harris is a customer of ours, but we're not Harris. We don't run it the way they do, where they'll have thousands of engineers, and the entry-level people spend 5 years not really engaged in anything really significant. Our people are out there on the front line immediately when they arrive. And that's not suitable to everybody, but anybody who has entrepreneurial skills or interest, they'll find it's a fun place to work. We don't do things if it's not going to be fun to work on. And it's a collegial type atmosphere. And there's a lot of interaction with customers, and a lot of interaction with the senior people. Senior people are as available to everybody as they are to each other.
Okay. Here is one from Mina, our finance director. Do you have any recommendations for current students on how to get involved in what kind of experiences in student groups would be valuable as part of their academic pursuits?
I've talked to some of the young people that have come to work with us, and I think that there are the types of projects that are available at the universities now, where a team of engineering students will work together, maybe with a faculty member, on something novel. Well, they'll be trying to develop something. That sort of experience, where they're out there working on a drone or some sort of thing like that, really establishes that creativity, that desire to develop things and invent things. And so I believe that those sorts of courses are available. Maybe they're seminars or things like that.
Here's another from Scott Banks. UF announced yesterday a $70 million initiative with NVIDIA to develop AI across UF. Is AI or machine learning used in your engineering efforts now, or do you expect to use them in the future?
We're using robotics, and we're using software that if we had the artificial intelligence, it would really enhance our productivity. Because to have people using the software and having to program it to work is an arduous task. So on the electromagnetics, what happens on the electromagnetics, the senior engineers know what is going to work, the concept of how it will work. And then they'll hand it off to the engineers that maybe have 10, 15 years of experience to start working on the electromagnetics design. But the software that they have to use actually is an optimization software, which is a trial and error type software. It's not artificial intelligence. In other words, it just keeps trying different iteratives of the design to see if something works better than something else. And because we've got large computers that do it, reasonably quickly. But if the computer were able to understand the path to the solution by the trial and error method, not to keep randomly selecting things, but actually going down and selecting the correct thing, then it would improve the end result, and it would do it much more quickly. So we have a need for that, yes.
It also seems to me that, you made mention of a steerable antenna that you have. Seems like AI would be helpful. And I guess that's what you were referring to just now. AI would be somewhat helpful in the designs and optimization of those steerable antennas that you're currently working on.
It would be. And the whole idea of a steerable antenna, it's a good point, is that the steerable antenna is an array of maybe a few thousand very small antennas. And the way you steer the beam is you adjust the phase and the amplitude of the signal that's going to each element, each separate little antenna. You adjust the phase and the amplitude such that it steers the beam one way or another. Now, there's some very sophisticated ways to do that, but the problem is that if you try to do it with brute force, you have so much losses that it doesn't work very well. So the artificial intelligence definitely would help in the beam steering.
Earlier, you made mention of one of the examples you gave was precision agriculture. And if I'm not mistaken, you talked about requiring GPS with, very high accuracy, millimeter requirements. Just out of curiosity, why would knowing exactly where that seed is to the millimeter be so critical? Just a curiosity. I'm fascinated by that.
Yeah. The idea is that each seed is placed in soil that is different in some respects to every other seed. So if you fertilize the whole field, you put the wrong chemicals on a great percentage of the seeds, so it doesn't work out very well. Plus, you've spent a massive amount of money just fertilizing the whole field rather than fertilizing the soil around that exact seed. Sorry, not seeds.
It's just the level of accuracy that's required. That's just mind-boggling on that example. Yeah,
you have to know where that seed is rather than the one that's a foot away.
Yeah.
If you fertilize somewhere in between the two, you didn't accomplish anything. And the savings on fertilizer is a tremendous amount of money too.
Don't want to hog the questions here, but I have one again regarding SpaceX. So SpaceX and OneWeb and so on had these mega constellations that they were going to deploy so that we would have global internet access from anywhere on the earth. And I believe OneWeb is filed for bankruptcy because of the pandemic or something of the sorts. Do you see this as a real, will SpaceX be able to do it? That's the question.
I'm not going to answer with respect to SpaceX because I have a non-disclosure agreement with them. OneWeb was challenged by the way they were structuring their business, and the way they structured their business was it was unlikely that they were going to succeed. There's basically three companies that were large enough to accomplish this. One was Telesat, Canadian company, then SpaceX. And the third was OneWeb. And OneWeb was, it was unlikely that they were going to succeed. It's not that they're really competing with each other, although there is some competition. It's really whether they can execute the plan. And the plan is speculative for all three of them, of course. But it's possible that these low Earth orbit satellites will be successful. There's some articles out there. There's a MIT article that analyzed the likelihood of success for the three of the companies. It's a pretty good read. If somebody was interested in that, I could dig that up and send it to you.
Yes, that would be nice to share. Okay, here's another question. Do you have any insights on what soft skills would be beneficial for the students to gain as budding entrepreneurs? The department is keen to explore training opportunities that supports this. And this is from Amina.
I'm probably not the right person to answer that. One of our engineers could probably answer that. I think that in our company, we do that teaching directly with the new people, and it's not that difficult, but it's a change in the way of thinking about approaching problems, basically.
Okay, so as an academic, I'm going to put you on the spot. I'm going to give you a homework assignment. You said you have an engineer on site that could possibly answer that. Could you reach out to them and just get back to us with that?
Sure,
because I think
absolutely.
it would be quite helpful for us.
Yeah.
I think that's about it for today, unless there are other questions. I'm thankful for the insights that you have provided to us, and really looking forward to the interactions between our students and your organization. I want to thank all those that attended and those that asked questions. And we will continue to offer this series of lectures in the fall semester. So please be on the lookout for that. Have a great day, everyone. And Mike, do I need to get anything from you? I did not get a response, so I take it that that's it.
It was a privilege to do this. I enjoyed it very much. Thank you.